Hello world, today our group will be doing a demonstration on how one can compare and display objects.
For the sake of explaining the basic ideas of our concept, we will be using the idea of a house as an object. The number of different rooms in the house are the instance fields, like the number of kitchens, bedrooms, living rooms, and so on.
For example, Steven's house has one living room, one kitchen, and 3 bedrooms. This means that when you call upon Steven's house object, you will be directed to these values.
Now to set up our main example. We have two homeowners, Abby and Shinujin. Abby's house has 1 bedroom, 3 living rooms, and 1 kitchen. Shinujin has 2 bedrooms, 2 living rooms, and 1 kitchen.
If we use a method that checks if Shinujin and Abby's houses are identical, we will of course get false. However, if we compare the number of kitchens, we will get true because they both only have 1.
Now, Slim just failed all of his classes in Waterloo, and he is now homeless and without money. He goes to Shinujin's house to stay for a while. Because of this, his values now point at Shinujin's values.
If you compare Slim's house values to Shinujin's house values, you will of course find that they are the same. Also, comparing Abby's house to Slim's house will have the same effect as comparing Abby's house to Shinujin's house.
After a while, Shinujin realizes that Slim is a total slob and is not fit for a roommate. Shinujin then kicks Slim out, and he is forced to go to his second choice, Abby. This makes it so Slim's components point to Abby's components.
Now, similar to the previous situation, when you compare the values of Abby's house and Slim's house, you will find that they are the same. Also, comparing Abby's house to Shinujin's house will have the same effect as comparing Slim's house to Shinujin's house.
Now say Shinujin wants to sell his house. He will have to send out the information about his number of rooms to the realtor and then give that out to potential buyers. This process is similar to how one displays their information about an object in Dr. Java using a toString.
Similarly, Abby and Slim are now selling their house together. They both send out descriptions of their house to their respective real estate companies, and they are obviously the same. This is also similar to Java outputting, because outputting Abby's values will be the same as outputting Slim's. Alright, that is all. We will now show you the way to do this all in Java.
Now that you have seen the unplugged version of comparing and displaying objects, we're going to show you how to do that in Dr. Java. Instead of using the house example, we'll be working with the standard quadratic equation, otherwise known as the form ax squared plus by plus c. To start off, we're going to create the object essentials, which includes the instance fields and constructors. A quadratic equation consists of an a value, a b value, and c value, which we will all be making our instance fields.
We will also be creating our basic constructors. Our first constructor is our default constructor, which assigns a, b, and c as 1, 1, and 0. In our second constructor, the user inputs the desired values of a, b, and c. With this, the user is now able to create a quadratic object with any integer value they want. With the program in its current form, it is completely useless for the user, as there is no way for the user to display it. Now we will show you how to display this object. The first step is to name this method public string to string. This is needed because the word toString specifically calls the command embedded in Java, system.out.println.
It will return a string variable that will be outputted every time that this object is called in a system.out.println, so this method should end with the return statement. We then break down the components to separate variables xcomp, ycomp, and zcomp, and at the end we will string them together for the outputted variable.
We put in an if statement at first to check if the 3 values are equal to 0, and if so, the statement to return will just be 0.
Now we will cover the other cases for a. The first case is when a is just 1, and this should print out x squared.
The second case covers when a is negative 1, and just prints out negative x squared. The third case covers when a is 0, and just prints out nothing.
The last case covers everything else, and it just prints out the value of a and x squared. With that, we have finished the cases.
Similarly, we have to repeat these cases for the second component and the third component, b and c.
The only thing that changed in those two parts are the cases for the components. One when the preceding components are 0, and one when they are positive. These are just added to make the output look better for certain cases.
After that, we put the 3 string variables together and return the output. With that done, we have finished our 2-string method. As you can see, our 2-string method works beautifully. Now on to comparing objects. To start off, we will make a method called isEquals, which returns true if the values of all the fields of a quadratic is equal to all the fields of another quadratic. This is much easier than comparing each field manually, making it easier for the user. Our isEquals method works great.
One concept that you guys must understand is that of pointing and linking objects. For example, say you declare the quadratic object comp and set its values to 2, 1, and 3.
Now, when you create a new quadratic object named psi, you can make it point to comp's values by writing psi equals comp. Making one object point to another means that they both share the same values, and if one value changes, the other automatically changes as well, as if they are linked.
This is demonstrated by changing the values of psi after it was linked with comp and printing comp out. These are the basics of comparing variables seen through the concepts of pointing and linking objects.
Thanks for watching!
No.
You didn't point at me.
I didn't point, just go.
It's too late. Bloopers. Stronger. Yup. Go.
This is for you, Mr. Cardoso. This is what we had to do just to film our stuff. We each had to lie down here, and put the iPad here, and line it up with this whiteboard, and then have a bunch of back problems as we drew our stuff here. So we better get 100.